Hi, this is a tutorial from AHA 3D Innovations regarding various options available in KISSLicer and all the settings that are available to you. And with me here is Mr. Tarun Srivastav of Tishitu. So this is going to be an interactive session on KISSLicer. Here we go. We start by launching the KISSLicer binary. So here what you should note is that it is a licensed version of the software, and if you need your own license you should go to www.kisslicer.com and buy a license for yourself. And without this license you cannot generate dual extruder G codes. So that's what. And this software is used along with the Proto 999 by AHA 3D, which is a dual extruder machine. So that's why we need a licensed version of KISSLicer. So here we are going to discuss various options here. So Mr. Tarun here will prompt me whenever there is some doubt.
So I like to go for the first basic interactive things the first user have to know, like they have to go for some style and support, material, MG codes, printer. Still I don't know the meaning of those things, but I like to very basically go to need about these things, how the thing is effect to our print. Okay, so first we are going to go for a style things, and I have seen some numeric numbers, but still I don't know what the meaning of those things. So first I like to go for the sample style, what this thing means to us.
Alright, so first let me begin with explaining that all the options and the numbers that you see here are coming from the preset files. So the preset files are given along with the printer, and we simply load those preset files in the software to get these numbers. And we are going to proceed step by step, and first we are going to take a look at the numbers which will be most commonly used, which you can tweak most easily to get good result in your in the output print. Yes, so we are going to use this support sticking test.stl as our example design. It is a nice small little test design which has an overhang and which has some features over here which need support. So this can be a very good guinea pig for us. So we begin with the layer thickness parameter. This seems to be the most interesting parameter, and this also tells you how precise your printer is. So layer thickness is nothing but the Z height of each layer when the print happens. So with the Proto 999 you can go as low as 0.05, but as a practical option, if you need really fine prints, 0.2 is good enough for you. Number 2, extrusion width and infill extrusion width. These figures, as a rule of thumb, should be equal to your nozzle diameter.
And extrusion width, both are. There is infill, I have seen. First extrusion width, that is in this thing.
Yes.
This thing I know. First I like to go for know about what this thing affect our printout.
Yes. So let me just slice the software and then take a quick look at the paths that are generated. So here you see these various lines. Each of these is an extrusion. So this extrusion width 0.4 means the gap between these two lines is equal to 0.4.
Okay. That's right. Means the body layer or a wall thickness of particular object that we are mentioning here.
Not exactly wall thickness. We call it the road width. Yeah, so each line that is deposited is equal to 0.4 millimeters. That is what 0.4 is. And the infill extrusion width means that if you see these thick, the widely spaced lines here in these layers over here, they are the infill. So here we are mentioning that even these infill should be equal to 0.4 mm. As a rule of thumb, this is driven by hardware. We should set it equal to the nozzle width. So in the case of Proto 999, it is 0.4 mm nozzle diameter. So we have set both of these parameters to 0.4. Okay.
What effect if I go for a 0.3? What the outcome of that thing is?
Yeah, so if you write 0.3 over here, it is going to anyway generate G code for you, and which will be a working G code. Like if you see, it has become more dense now. So you will get a successful print, but now you are basically depositing 0.3 mm spaced lines with a 0.4 mm extruder.
Okay. So the thing is overlapped.
Yeah, they will overlap. Although it will always regulate the material. It will never put in more material than is required.
Okay.
But they will overlap, and of course the accuracy will not be equal to 0.3. It will only be equal to 0.4.
0.4. Okay.
Yes.
The outcome is on 0.4. If you going for, if I go for a 0.5, then there will be a gap.
Yes, there will be gap. So the software will instruct the printer to put out more material per length.
Per length, exactly.
So that the same material, then the material will come out and squish out basically.
Okay.
So that to fill in the gap left between two rasters.
So the basically knowing to the person that who is operating a printer, and they have not to change the value of 0.4 to 0.5.
That is recommended. Yes, unless you are very sure what you are doing, the 0.4 is a good working figure. Yes.
Okay.
So I think we should proceed with the 0.4 figure right here.
Okay.
There are cases when you will want to make it 0.3. In case you are doing some very fine prints and you are not getting your tool paths generated,
okay,
then you can always force the software to generate tool paths by lowering these values. But the resultant print will not be equal in accuracy to the initial design.
The initial design. Okay.
Yes. So
okay, the layer thickness in mm that you already told about, if you go for a 0.1 or 0.2 is the best for taking an output things, huh?
Yeah, 0.3 is generally works, but if you want some really fine prints, 0.2 is good. If you are still not happy with the output, you can go to 0.1, but always remember it is like doubling in time. So if you go for 0.2 to 0.1, the print is going to take double the time.
Okay, if I go for a 0.1, what should I go for a fine printing that I go for a settings? Like there is some option here is fast and precise, or
yes.
Is this thing is effect with this thing the fast and precise?
Not really. Fast and precise is instructing the printer to make its moves by a certain speed. So you can take a look at these speeds over here.
Okay.
So it is instructing the printer to make its loops at 53 mm per second, to deposit solid layers, that is the top and the bottom layers at this speed, and sparse layers at this speed. So sparse is equivalent to infill. So you can always tweak this slider to make the print go fast or slow. But always remember, this is not a runtime adjustment. This is a time of adjustment at G-code generation. So your program that will be generated will have these speeds embedded into it.
Okay, a very basic layman term, what this thing effect if we go for a very normal going people they are operating this thing?
Normally you can keep it over here so that your loops print at approximately 40 mm per second. So for a layman it means that the faster you print it, the lesser accuracy you are going to have.
Okay.
And we have tested our printer extensively at these speeds. If you are printing loops at 40 and solids and infill at approximately these 80, you are going to get acceptable accuracy, that is plus minus 0.1 millimeters.
Okay.
If you exceed these speeds, you will get lower accuracy, but your speed of print will increase.
So what will the best value if you suggest for any type of print we are going for? Any
type of prints, this is a good value.
65 right. And
yeah, so loops at 40 and infill at 60.
Okay.
So this is a pretty good
spares of 80. Okay,
spares of approximately 80.
Okay, the skin thickness here in mm, what means its skin means?
So skin is basically the shell of your print. If you notice this design, by design we have here as a solid block, but when we actually print it out, it is not printed as a solid block. It is broken into the wall and the infill. Correct. So if you take a quick look, let me slice it again. You will notice that, for example, this layer you can clearly see the wall. it is made up of 3 rasters. So skin mentions the thickness of this particular. So these 3 taken together will be equal to 1 millimeter.
Okay.
That is this.
Or
the outer periphery.
Of the
print.
any of the object.
Correct.
Means is going up to 1 mm.
Yeah, it will be 1 millimeter, and it is useful in case you want to post process your prints like sanding or any such thing. So in case you need a thicker wall so that you can later on sand it down or do some like acetone bath or anything, then it will be useful if you can
go for 2 or
yeah, you can even
go up to 2.
You can even go up to 2. Yes.
Yeah. So it will be more stronger than of the previous wall for a 1 mm thickness.
Precisely. You are going to get very strong prints. The more you have, the wider the skin, the stronger the prints are. And the number of loops over here tell you the count of the
layers.
Yeah.
The wall layers.
Yes, the number of rasters in the wall. So we can make it 2, and you can see the effect here. It is going to force only 2 layers in the wall.
Okay.
And yeah,
so means 1 mm thickness with the 2 layer of wall. So if you go for 3 numbers of loop, the thing is more thicker and stronger, and for 1 mm wall. Is it correct in the time?
So it's like you are anyway getting 1 millimeter wall.
Okay, yeah, exactly.
The wall thickness will never change, but the number of times the head goes over to make that wall will change. Means so right now,
means the material providing to the wall is same.
Yes.
Okay.
Yes. So for example, now we are making 1 mm wall with only 2 loops. So each loop will be 0.5 mm.
0.5, exactly.
But if you make it 3 and then slice it, in this case each wall is going to be 0.33 mm.
0.33 mm.
Okay. So and another interesting aspect is this insert surface feature. Normally it is 0, but in case suppose you are trying to make a mating part like nut and a bolt.
Nut bolt, exactly.
Right. So in design, suppose you have not kept any clearance.
Okay.
But now here in this software you have an option to insert to enforce clearance. Okay. So if you for example make an insert surface of 0.2 mm, what it will effectively do is it will it will shrink the entire design by 0.2 mm from all the faces.
Okay.
Yeah. So this will be very in this example it is not very useful, but if you are printing a nut
bolt,
then nut and bolt, so if you insert each one surface by 0.1 mm, then you will have a 0.2 mm clearance in the final print.
Means if you are knocking a nut or that surround, then it will give the tight effect or loose effect.
Yes, precisely. So yeah, if they are not fitting nicely, you can always increase the inset value to get a good fitting.
Good fitting, exactly. What this thing infill 20% in there?
Yeah, infill is the solidity given to the innards of the print.
Okay.
So if you notice it here, so for example if I slice it with 33% right now, it's a very tiny print, so it's not really very clearly visible here, but you can take a look at this layer. Now notice the density of these
supporting
lines. So we call these the infill lines.
Lines, okay.
So let me make it octagonal so it is more evident. So these are various patterns of the infill. So here now it is trying to do, octagons are very small, but still you can make out.
Okay, if I go for 50% or 100% infill, then
if you increase the infill, then these octagons are going to become more dense.
Okay, means the support to the wall or their rigidity is increased.
Yeah, it is increased. The solidity of the entire object will increase.
Okay.
So if you need
what that octagonal and this thing octagonal.
Yeah, so these are the infill styles.
What these infill styles help us to go for an object, like if I go for design something with the straight lines and octagonal lines and rounded, what will the effect actually goes with this thing?
Okay, so as a rule of thumb, if we look at only these three options: straight, octagonal, and rounded.
Okay.
Straight is the fastest infill. It will take the least amount of time, but it will also be the weakest.
Weakest. Okay.
Okay. Octagonal is a good trade-off between straight and rounded.
Okay.
It will give you pretty strong, because it is based on the honeycomb structure.
Yes.
So it is quite strong, and at the same time it is reasonably fast. Okay, rounded will basically put in circles inside this, so it will basically make the infill with arcs. It is the strongest, but it is the most time taking option.
Okay, does it affect our machine if I go for octagonal or rounded?
Only the time taken of the print will be affected, but machine can manage everything.
The jerk and those things are
jerk and all
manipulated
that
in a hardware.
Yes, that will be taken care. Okay. So
there is some stream hiding or jitter. Is this something
this
that I go
is
for?
also interesting. Right. So jitter here means that the starting point of basically suppose you are making a cylinder. Okay. And basically it's a wall, I would say, a cylinder. So it will basically put on circles on top of each other to make the cylinder.
Okay.
Correct.
Yeah.
So if the start point is always coming to the same place, then in the end of the print you are going to see a seam of blobs.
Okay.
So the entire cylinder will have a very noticeable edge, a seam. But if you introduce a jitter there, it will basically scatter the start point of all the circles all over the cylinder.
Okay.
So that it won't make a continuous seam, but it will rather scatter those blobs all around the cylinder. I don't know if it is very clear. You can please ask.
Sure, but I go for some design or something where the jitter is used. In the next video, surely we can discuss in the things.
We can do that.
Okay. I've seen there is something. All the thing is in there. What the count is there up there, and height, and this thing is mentioning over there.
Yes. So here it is giving you a very quick preview of your design.
Okay.
It lets you do some basic things, although it is not as powerful as some other software, but you can at least always control the number of objects you can print. For example, you want 4 of these, you can just increase the count. Okay, so you'll get 4 of these, but I may be wrong, but I have not yet found a way to place these manually.
Okay.
The software will decide where they should print.
Okay, that's good. The thing is handled by the nearest path or the shortest area it will go for. So it will decide by a software that the thing is to be printed.
Exactly.
Okay.
And this angle is the angle of this entire object. Okay. So for example, you want to in one it will be more clear. So here you can basically control the angle at which the object is placed.
Is this thing something matters to if I go for some different angles?
In a single print it doesn't really matter.
Okay.
But if you are trying to fit in a lot of prints in a single plate, and you are basically trying to squeeze in many models, then probably adjusting some angle will be helpful.
Okay. The thing height is mentioning means?
It is just a preview thing. It is a preview thing. I think you cannot really change it from here. Oh, you can change it. Oh wow, this is a new thing for me. So basically you are okay, fine, so you know it. Right.
So we can change the actual dimension by the Okay, I got the angle of things like 270 degree or how much degree you want to rotate the thing. In some print it will be helpful. Okay, the thing I have seen, there is 7 actual height is given by a software to this software. Means if you are using SolidWorks, AutoCAD or 3D Max, then from those you will get the precise output with the perfect dimension with having a ratio of 7. if I change the value, what will happen the thing with this? Like if I go for just double the height of this thing, what should I go for?
Yes, so basically here you have an option to increase the height of the object. By default it is showing you as you mentioned that it is coming from the CAD data, but you can always change it and it will proportionally scale the object to make the height like that.
Okay.
So for example, you can make it 14 right here to effectively.
So it will just double the height, and from all the XYZ ratio it will increase the thing. Okay. So the reset is means to reset the all values. This is the same thing. Okay. Reset means the object is placed in a different single manner, or the center of the thing maybe.
The view is reset.
Okay. What if I change the position of this thing? How should I go for?
There is an option here at the bottom right corner. The center. So you can always place your object using these sliders.
Okay. Means we are free to place the object here.
Yes, so these sliders, and if you are not happy, you can always make the big center.
Okay, so it will always be in a center. Copy style, it means.
So okay, the thing is that suppose you have made a particular set of values that you are happy with, and you can basically copy all these values and give them some name. For example, my style. Then all these values will come into this drop down box of my style, and you can always go to some other values, make other set of values which are suitable for some other kind of prints, like fast prints or coarse prints. Or
if we have a different print and we have set of number of prints we have, so we can give the name of screw and bolt, and if we are making the things, or we are making a ball, so we can go for a multiple style. How much style we can go for introduce in this?
I don't really think there's a limit on this, although I'm not sure, but he's basically writing a text file from all these settings, so text file practically should not have a limit.
Okay, it will go up to that.
Yeah, so whatever amount you want.
Okay. So shall I go for the next thing, that is style? First we have completed the style and we can go for a support.
Yes, I think we have covered everything on this page.
Okay. Support it means?
Yeah, support is basically the extra tool path generated by the second extruder or the first extruder if you only have a single extruder machine, to fill in, to basically support the overhangs like this one. Okay, so for example, this over here is an overhang, and the program, the KISSLicer software is going to generate some plastic below this.
Okay.
That plastic is called support.
Means we are constructing some homes and something. If I go for a ceiling, there is some pillars we have to stay over there for 2-3 days to make it balance. So same as like this thing is.
Yes, you got it right. You put it in a very nice way.
Okay.
You basically support is generating those scaffolding structures which will be removed later on. So in the case of Proto Center 999, you can generate it with a soluble plastic, and then you can always dissolve that away.
Yeah.
So here the sliders are basically telling us what is the density of the support that we want. Typically medium is a good value to work with, and this degree of support is basically the degree from the vertical beyond which it will generate supports.
Okay, means if I having an object and what nearby the angle or that support to be balance the thing, the angle.
Yes. So I think let me find if we have some good. Actually, I think it will be best demonstrated with a different STL object. Okay. So probably we can take this point later in the next video.
Sure.
Yeah, but as for now we can just see that support of 40 degrees is a good point for the Proto Center 999.
Okay.
You should never face any problems in that. Next is the sorry, you want to ask?
Yeah, please.
Alright, so the gap is basically the gap between the object and the support structure.
Okay.
Yeah, so a gap of 0.8 is good enough, but you can decrease it to probably 0.2 or 0.3 if your object
very
is
much near to the object, so
yes.
Maybe it will stick it with the wall or support.
Yes, so the support will come very close to the object. The smaller this value is, the closer the support is going to be. You can safely go down to 0.2 mm and the Proto center will not really touch the support to the object.
Okay, well, that's okay, but that raft thing is, I think, important to go for that skirt and
yes, exactly. We can cover that now. Raft is basically supporting structure for the main print. Okay. KISSLicer gives you 3 options: skirt, grid and pillar, or of course you can turn off the raft. So skirt, if you take a look at the sliced output, the skirt is basically this loop that is made all around the print. This is the skirt option of the raft. You notice this?
Yeah,
loop.
I've seen it.
And the grid basically tells you to make a grid below the print. So if you take a look at the first 2 layers, this and this, these 2 layers are the grid which is generated using this option. And pillar, I'm also not very sure. Let us take a quick look what it is doing. Really sure what it has done. Oh wow, it has basically generated pillars underneath the print. It is basically making the print ride on a lot of tiny pillars.
Okay.
So
what this thing helps to go further to
it apparently, if you let this one print, it is going to lay all this grid of tiny dots and then print the object on top of that, so that removal will be very easy.
Okay. Exactly, for extraction and removal.
Yes. But I suspect that if you print it out, if you are doing it in ABS, warpage will be a problem.
Okay.
Warpage will be a problem. Yes.
Means if I sticking out the thing, it will be more difficult, or will break the thing, something like that.
No, the point is it will be too easy to remove.
Okay.
So if the plastic wants to bend, it may break all this raft by itself.
Okay.
Without.
So what will be the best option to go for if you?
We basically recommend skirt.
Okay.
And generally we go with the acetone cement layer. So acetone cement is a good enough option to hold the print. And the skirt always ensures that the head is primed before it starts printing.
Okay.
So raft skirt is a good option.
Okay, the inflated raft is something 0.
Yes, actually we have 2 inflate options: inflate raft and inflate support.
Okay.
So it is basically extending the option beyond what is required. So let me start with inflate support option. So right now, if you take a look at this yellow support over here, you see that it is very nicely fitting underneath the object. But if you inflate it by say 2 millimeters, then it is going to extend the support structure 2 millimeters outside.
Okay.
You notice this one?
Yeah, exactly.
It is basically extending, it is inflated the support structure to project outside the print by 2 millimeters.
But what this thing helps to us?
Sometimes it may be useful to you. We have not, honestly speaking. Yeah, one use case we can think of is that if the support structure is very tiny, it is like very minute support is being generated,
okay,
then you can force it to generate bigger supports using this option.
It means if the thing is on the layer or having some extrusion, a ball or balls are bit outside of 0.5 mm, then it will be helpful, or maybe a structure is more stable instead of that yellow
precisely
thing.
Structure will be more stable
to hold the thing
yes. So that will be useful. Right now let me make it 0, and inflate raft will nothing but inflate the raft beyond what is required. So here if you see, the skirt that is generated is now 5 millimeters beyond what it was earlier.
Yeah, exactly.
So it has inflated it. Alright.
Okay. And I've seen a support Z roof what this thing?
Yeah, so this is basically enforcing the support only up to a certain height. Okay, let me try to elaborate. -1 millimeter means that you can it will basically generate support whatever is required. But suppose if I make it a positive value, say 2 millimeters, then it will generate support only up to a 2 millimeters at height. After that it will not generate support.
Okay. So the object, what will be the outcome of the print? Is it disturb the print if I go for the value?
Yeah, it will definitely disturb the print in this case. For example, here if you see, it has, you can take a look. Inside, it has generated support. Here you can take a look at the Z value here.
Yeah.
As soon as it goes up to 2, the support is no more generated.
Okay.
So obviously it will make this an unsuccessful print. But the software assumes that since you are overriding its suggestion of a -1, then you probably know what you're doing. So yes. So that's what support Z roof is basically forcing. Yeah, it is.
This should not be changed by a person if layman person
Yes.
is going to.
There is no need to change.
No need to change. Okay. So.
So over to the material.
Oh, material.
Essentially, there is really nothing that we should change here because all of these values are they have come after a lot of trial and error and spending a lot of hours with printing with the material that we supply with the printer. So changing these will there's a risk that probably the print might fail. But we can do a very quick review of what all the options mean. The diameter means the diameter of the filament. The temperature means that for this particular material, what is the temperature? Normally we have we are overriding all these options by using the preheat option in the machine. This is the D string option, that when the printer is printing and suppose it is making two structures nearby, when it goes from one structure to the other structure, it normally it will make a trail of plastic between these two, but we can avoid that by the D string option. So essentially it will suck the material 3 millimeters back, then go to the next structure and then prime it again by 3 millimeters and then start printing, so that there will not be any strings between the prints. And these are the fan options. So we don't need this in ABS prints anyway. We get pretty good results without these, but for printers with fans in them, we can define that when the fan should turn on and turn off. And these are the flow adjust settings. These are tweakable settings in case there is some hardware problem in the printer, but for a perfectly tuned printer there should be no tweak required here. And this is the Z lift. I'm not really sure, I'll just have to take a look at the tool tip to remind me what this is. After a D string before a travel, lift the head. Alright, so okay, so a D string will be followed by Z lift if it is enabled. So, but
means the normal person or to be print and the layman person, they have not to go any changes on the material.
Yes, precisely.
Okay.
Unless you are doing your own experiments with your materials and all, you will not need to change all this to get successful prints.
Okay, that's
with the Proto center. So because all these settings are coming
from the machines what the provided by a company that are printers.
Yes.
Yeah. The mat G code is
a material G code is like an option provided by KISSLicer. This is some G code to be run along with the material changes and all, but we don't use this option.
okay. So for mat G code, the layman person, they also don't have to go for any settings on these things.
Yes.
To be modified.
Yeah, we don't have to modify.
Okay.
Correct.
So the material and mat G code is not to be modified. Next, the printer is.
The printer option.
Okay.
This one here we are basically defining the hardware of the printer and some other parameters. So here you can see that since the Proto Center 999 has 2 extruders, we have defined a number of extruders as 2 here. The bed size is 230, 230, 230, and the bed center is 0 and 0. So basically the center of bed is 0, 0, and XY goes from minus 115 to plus 115.
Okay.
Okay. Bed roughness, in case the bed has got slight imperfections in it, then this bed roughness setting forces the material to be deposited. For example, if I write a bed roughness of 0.25, then the 0.25 mm of plastic will be deposited before the print.
Extra print means for a very starting of the printing.
Yes.
The extra 0.25 mm of material is to be firstly deposited on that thing.
It will deposit, then it will make.
Then it will make the, because from further it will there is no need of roughness of it, because there is a layer already extruded.
There's already some plastic.
Some plastic is there.
Yeah.
So
But in case of Proto Center 999, we are using precise toughened glasses. So they have practically 0 roughness, so you can safely write 0 here.
Exactly.
Z settle is basically upon every layer change, it forces the bed to overshoot by Z settle amount and then rise back. But again, for our purposes, Z settle of 0 is quite good. We don't need anything. Z offset is also a setting needed to compensate about hardware mistunings. But in a properly tuned printer, you don't need any Z offset also. So
bed STL model, what this thing, what should we go for this thing? Does it concern for a printer?
Honestly, we have never used this setting, so I am not the right person to comment on this.
Okay, so there is no need of
yeah, but there is no need to. Yeah, we don't. Definitely, we can work without this.
That's good. So in there, I have seen hardware and firmware thing.
Yes.
So firmware, what
So firmware is basically telling the family of firmware inside the printer. Basically, the KISSLicer software will generate G codes compatible to the firmware that we select here. Okay, so in our case it is equivalent to 5D absolute E. So this family of G code works easily with the Proto Center 999. Okay.
And the file extension is G code. We can go for change the value, or
yeah, you can easily change anything. It will just affect the name of the file, but the language is.
It will accept by a printer like
yes.
xyz.g if I said.
Yes, yeah, printer will use it, no problem. You can write anything and printer doesn't mind.
So I can go for my company name .something.Tishitu.
Absolutely.
Okay, so it will go for work on keep. Okay, that will be my. So
you can
fan, yeah, exactly. Fan on, fan off.
Fan on and fan off G codes. Again, this printer doesn't sport a fan, but this is useful for the printers that have fans on them. Actually, they are more useful for PLA. Printers who use only PLA. So that's why. But anyway, when the printer will generate G codes using these fan on and fan off commands, so you can change these. But again, for a layman, these settings doesn't really matter. All these are by default, whatever they are, they will work. Then over to the extruders tab. This is a pretty good place. You might need to come back here sometime. Here we are basically telling the printer, the KISSLicer software, that in the extruder 1 I have loaded my ABS black filament, and in the second extruder I have loaded the HIPS filament. Okay, and the extruder map specifies that the object should be made with extruder 1, interface and the support should be made with extruder 2, and raft should be made with extruder 1. So this is a very good working value set. Object extruder 1, interface and support extruder 2, and raft with extruder 1.
Okay, does it help if I'm having some problem and I have to submit my that print to a company and I failed the second extruder to be printed? Is it helpful here to go for the change the values or those things that will support will go with the single extruder?
That's a brilliant option that you thought. Yes, it is possible with this particular printer. So the question, if I get it right, is that suppose my first extruder has failed. Okay, now I want to put ABS in my second extruder and make a single extruder print, right? So what you need to do here is that in extruder 2 you need to select ABS black, and in the object tab you need to select extruder 2. So then you can the G code that will be generated will use extruder 2 to make your object. Okay, so yes, you can do that. Let me revert it to the original value. Yes.
Okay, so if you want to go for a single extruder, go for a 2. I'll go for 2 and 1. Yes. So everything is.
Suppose now you made 1 here. Then now in this case it will generate support with the main material itself.
Okay, so shall I go to change this thing too?
No need to do that. Here basically we are mentioning that extruder 1 has ABS in it and extruder 2 has HIPS in it. Then in the extruder map over here we need to define that object should be made with what extruder, support should be made with what.
If we don't change the extruder 1 and extruder 2, it will keep on going for a print.
Yes, using these values.
So it's okay to go for changing these only.
Yes, exactly. So yes, so essentially you only need to change extruder map here.
Okay, the basic value is 1221.
Yes, this is a good working value.
Okay, so about the speed.
Yes. So speed is basically letting you define how fast the printer should make your object. Okay, there are 2 boxes here: fast, which is lower quality, and precise, which is slower. These 3 values are over here, and there is a slider over here. So at the left end of the slider, these values will match the fast values. Okay, and at the rightmost edge, precise will be the thing, and you can pick any intermediate value using this slider.
So means you have already provided the fastest value which will work with your hardware, that printer.
Correct.
And the slower value. So this will be the optimum result of this thing.
Yes, if you need really beautiful accurate prints, you should go with the slowest, the precise settings.
So we can change the 20 and 40 and 60 like this.
It is not a good idea to change here.
Okay.
Rather you should use this slider.
Okay, in a slider like this thing is having a 61 value or 65, we are having some different values.
Yes.
So this is the slowest best and this is the fastest best value what we got.
Best value, yes.
Okay.
Although I will like to mention that the printer can also easily print with 150 millimeters per second.
Wow.
Yeah.
Yes. So.
But like these are the recommended fastest and the slowest values that we suggest.
That's good. So shall I go for PTR G codes?
Yes, let's go there. Okay. So here we are basically giving some custom G codes to the printer. Again, these are very Proto Center 999 specific things, and these are not meant to be changed. So yes.
Okay, the prefix tab, there is nothing to be changed. Select extruder, this thing also mentioning, but there is nothing to be changed.
Yes, we should not change it, but let me walk quickly through all these options.
Yeah, exactly.
So prefix is basically all this code, the set of G codes written inside this, it will be prefixed in the G code file before any other thing.
Okay, shall I go for slowly move this thing where the person, if they have mistakenly changed the value, what the basic exactly value should they have to go for right on?
Yes, they can look at these and you can always revert to the factory values by overwriting the INI files with what we have supplied.
Okay, no, if the INI file is mistakenly changed, then this will help to you for the best of what still I get the inner firmware.
Sure.
Okay.
So then you can also preview the select and deselect extruder options.
Exactly. This thing,
that's a good idea.
That's why I'm switching for single ones. Deselect extruder, these are the values, and there is nothing
here.
And postfix
is there. So all this code is copy pasted at the end of the G code by the KISSLicer software.
Then I've seen a miscellaneous. Is there anything that you want to tell to the layman or person?
Nothing other than make sure that these values don't change.
Okay, that's good.
Because then probably something will go wrong which we will not be able to easily debug.
Okay. So shall we move on to miscellaneous? MISC?
Yes.
Okay. What this thing?
This thing is again, I'm not very sure about what all this means, but I definitely know the meaning of the RAM warning option. That this is an option provided by the KISSLicer software. It gives a warning pop-up in case you load a heavy design and it is likely to use more than the threshold set here.
Okay.
So here we have by default it uses half of your physical RAM.
So does this thing affects when I load the above value, and if I change the value up to 2047 maximum value, then I put this thing on a G code to our printer.
Basically the software is going to use up the RAM required by the slicing operation, and it might slow down the other things, or it basically sucks away all the RAM.
Okay.
So the computer may become unstable.
So it doesn't affect our printer if I take a heavy G code value of file?
No, not at all. After the G code is generated, it may be any hundreds of megabytes. Printer never bothers. It will just start printing from the first
because it linearly take a data and keep the thing in the RAM, then after print out the thing, then flush out the thing what they have already taken.
Printer doesn't load all the complete file at once. Yeah, so printer doesn't affect, but yes, your computer may become unstable if you load a very big file and it exceeds the physical RAM available in the printer.
Okay, this will be affect a KISSLicer, not a printer, and output of the file what you have taken for a printer.
Correct. Precisely.
And okay, so I got all the options: style, support, material, MTL G code, printer, PTR G code, miscellaneous. So this is all about the KISSLicer. How do you keep on working with this thing? I have seen some file preferences on Moodle. Shall it be explained by things? It will help to us.
Yes, let me take a quick look to see if we might use some. There is a good option here. Suppose if you want to. Basically, the point is that the software is giving you an option of saving the STL back to the disk.
Okay.
This might be useful sometime for you.
Okay.
Other option is that the one very useful option is scale by X.
Okay.
So you can basically give a scaling factor. Suppose you want to make basically double the size of this particular object. You can just give a scaling factor of 2 and press OK.
Okay, same as like what we have changed directly by height option.
Yes.
So the thing is out.
By height, actually we mentioned the height and it proportionally scaled the other things. And here we can give a scaling factor. Yeah, effectively it is doing the same thing. It is resizing the object, but it's a different way to do it.
Okay.
Yeah. And well, I guess that's we have covered mostly all the options that we wanted to cover.
Okay. For a first print, I like to go for the thing what we have already set in this. So I'll go for 10 of values, whatever the ratio, I still don't know what the thing is output in there, and I'll go for a slice the thing, and I got something output. I'll go for a model and path both.
Here you can quickly preview that.
Preview how the thing will be next in.
So it has two dense.
Two then. So shall I go for 20 of filling?
That's a good idea.
Okay, I'll go for a slice then again, and I'll get some. Yeah, I got the some. This is good.
Okay, while we are here, I also want to show you one very useful thing by the KISSLicer software. Here you see that this particular support will be made by thin walls.
Yeah.
Okay, if you feel that it is too weak, there is an option here to sheath the main support.
Okay.
If you tick it and you slice it, then you will notice that it is making a boundary
Yeah, exactly.
around the support. So the support will be much more stronger in this case. So you can probably use this if you have this. Just wanted to show you so that you keep it in mind and use it sometime. But right now this will work easily.
If I want to see from up there, then I'll go for a path and make it zoom out bit,
Yes.
and then after make it from upstairs how the printer will keep on working with this.
Yeah. Incidentally, while we are at it, we can also see every layer how it is going to print.
Okay.
So here on the horizontal slider, it shows you the percent of mark. So first it will print this part, after that it will print this part, and after that you'll get this one. So that's it.
So bit by bit it will go to the particular layer and then print the things, na? So I got the maybe a complete thing about this, and then I go for a save the G code.
Yes.
Then I'll go for a save. I'll go to my desktop, that is much easier, or whatever you like to keep your file. So support the I'll take a small name, 66666 whatever. Then I saved it. Okay, I got the file on a desktop. Then I have to keep this with memory card. You show desktop. I got the 6666 value. I'll copy this thing. Just I have inserted my memory card to the USB connection. Just I open the file. There is one already file is present in there. I'll keep this thing and just drag this file on the drive, the removable disk drive, what already provided by Innovations. So this is the 666 G code I have put in my memory card. Then I remove the memory card. Okay, now the print is going to ready for a printer. Okay, thank you.